Hello, this is the 11th lecture of the electrostatics. In this lecture, we are going to discuss the topic potential energy of the dipole in a uniform electric field. This topic is also the part of the potential chapter, but we are now discussing in this chapter also because basically in the last lecture we have discussed the dipole, somewhat about the dipole and how to find out the torque related to it. In the last lecture we had discussed that torque torque is nothing but p cross e, means the torque is a vector quantity we had discussed in the last lecture. And basically we are going to find out the potential energy of the dipole in the uniform electric field. Now I think you know the work done delta W is when we are discussing in the linear motion. We discussed that the dW is F dot d. Yes, F dot dr, and then we will integrate it and then find out the total work done. Yes, from where the body is, from where to where it is body moving. For the this is for the linear motion. But we have seen that when the torque when the basically when the dipole is placed in the uniform electric field, then it on it apply the torque. Yes, body do not have any, basically then net there is no force on the body, there is torque. Yes, and then we simply say that then the formula for the work done when the dipole is placed in a uniform electric field, then we write the torque into d theta. We simply say that the torque into d theta is the angle of the rotation. Let's suppose the dipole moment is here and the electric field in this direction. This is the p vector, and then we know that when we apply the electric field, the force will apply to their endpoints, and then the body try to rotate in this direction. And then we are going to discuss this part only, the potential energy it will store, the dipole moment will store within it. And then this potential energy is nothing but torque into d theta. And if we find out the total work done, it is nothing but integration d tau and d theta. Let me consider that the theta 1 to theta 2 we are integrating it, and then just putting the values of the torque. Torque is integration d theta to d theta, theta 1 to theta 2. Torque value is if you can also cross product is nothing but the p vector into e vector sine theta. Yes, you must know this. This is the cross product simply. These are the, if I am not making the vector here, it is the simply magnitude. Yes, and then it come out to be p e sine theta d theta, sine theta d theta, and then p e are the constant basically. Because the electric field is uniform and the p is also independent upon any theta vector, because p is nothing but, you can write 2aq. 2a is the distance between a dipole, you must know. Yes, from the previous lecture you must know this fact. And q is the basically the any charge on the endpoints we have taken. And then we are integrating it from the theta 1 to theta 2 sine theta d theta, and then it come out to be, if we put the values, sine theta integration is minus cos theta, then pe minus I have taken outside, and then cos theta, theta 1 to theta 2, upper limit minus lower limit, and then you can write pe cos theta 2 minus cos theta 1, and then you can leave here also. You can make some of the special cases also by taking the by taking as theta 1 is equal to 90 degree and theta 2 is equal to theta only, then the potential energy, yeah, the work done is nothing but the potential energy. It work done is stored in the form of the potential energy only. And then the potential energy, yeah, you can say the work done is nothing but minus pe cos theta. Yes, simply theta 2 become the theta, and then cos 90 degree become the 0, and then you are getting this answer. And it is too simple, and just try to remember it. And some of the book also write down the potential energy, the work done is nothing but the this is the potential energy represented by the capital U, and this come out to be this vector. And you can also absorb into the dot product. You can write P vector dot E vector. You must know that A vector dot B vector is nothing but A magnitude B magnitude into cos theta. Okay, thank you then.